Hello everyone, today I'll show you how you can populate your interior spaces easily with the PCG system in Unreal Engine 5.3. You can see this room is filled with desks and they have computers and parts and tools over it. There are some cables below the desks and chairs. Everything in the room is placed by one PCG graph. I can edit the graph, the area of the graph, for example, by choosing this point, and you can see everything is being recalculated and placed procedurally into the scene. For example, I want only the half of the room to be filled with this, and then let's fill the other half with another blueprint with this PCG graph. Each desk have a computer on it and random arrangement of other computer parts or tools on top of it. It has some cables below and a chair that's randomly positioned, as you can see on the different desks. For the items for the interior, I used the Deco Matrix demo items. You can get them for free on the marketplace. Here in the meshes folder, I've used some of these assets. For example, you can recognize this chair, this desk. I have these tables. It's an easy process. You have to repeat a couple of steps for each type of the parts. But let's start and I'll explain everything while we place each part of this procedure tool. So let's delete everything. We have a blank room. And let's create a new blueprint. I already have the one you saw, but I'll create a new one. So let's create a blueprint class. It will be of an actor type to be able to place it in the scene. Let's call it blueprint PCG interior tutorial, for example. And inside this blueprint, I will need one spline and this spline, let's make it a little bit bigger because we'll be filling big interiors with it. There's no point of this small spline. And let's change the type to a linear for the points. Select each point and change the type to linear. Sometimes it doesn't change, so need to change it to some other value and then go back to linear. It's a little bit buggy, but it works that way. So by holding out, I'll create new points. Hold out again. And then choose this closed loop option here. This will automatically close the spline for you. Let's compile and save this too. And after that, we'll add a PCG graph to our blueprint. And we'll need to create a graph to plug in here. So compile and save this blueprint. Go back to your content folder, right click in the folder that you decided to create your PCG and choose the PCG options and PCG graph. If you don't have this, you need to load the plugins. You can see in my other PCG tutorials how to do this, or just search how to enable PCG tools in Unreal. So create the PCG graph. Let's call it PCG interior tutorial. And with this PCG graph selected, go back inside the blueprint and select this PCG component and click this use selected asset from content browser. It will select the PCG interior tutorial, or just drag and drop on top of this graph field. Either way, select this graph here, compile and save. And now, if I place this PCG interior tutorial blueprint into the scene, we get the spline. Let's cover more of our room here with this spline points. It's not doing anything currently because we didn't set up anything in the PCG graph, but now I'll show you how to start placing the objects. Okay, so I covered the room. Now let's go into our PCG interior tutorial and start creating our graph. First, we need to get the spline data for the spline that we have in our blueprint. So right click into the graph, get spline data. We'll search in the blueprint itself. So here is the self. If you're making a PCG graph that's separately placed in the level and it needs to search in the level for the points, you'll need to change this option here, but by making it into blueprint, I believe it's more optimized to only search in the actor itself, and it's easily controllable where to place everything. So go back to self here. Now we'll need to drag out from this data point and choose spline sampler. We'll sample our spline. We'll sample on the interior of the spline because we are drawing an area. So choose the dimension field and choose on interior. And in my demo, I have it set 120 by 100. So it will place objects roughly 1 meter apart in both directions. You can hit the D key to see where are your objects placed. You can see that we are not getting objects in the entire area. We need to click this unbounded field. Currently it's just selecting this area here. If we click the unbounded field, we are now properly filling the entire area into our level. So after we sample the points into our spline, let's spawn static mesh spawner, and into this static mesh spawner let's create a mesh entry. So select the static mesh spawner and into the mesh entries field click on the plus sign. Now you will have one mesh entry, and choose the descriptor, and for the static mesh choose the big desk, for example. Now you will see that you have a lot of desks spawned and they're overlapping each other. So to fix this problem, you will do some pruning of the points. So first you need to match the bounding boxes to the static mesh you're spawning to properly indicate which area is taken by this object, and then just prune the results in order not to spawn points on top of each other like it's currently doing. Let's do first our bounce modifier to modify the bounce to closely match the desk that we are spawning. So let's temporarily change this spawner to 500, 500. Let's remove the debug visualization by selecting this and clicking D again. And now let's create a bounce modifier. So drag here and start typing bounce, create bounce modifier. And this bounce modifier, we need to set the exact bounce that we need. So now click on the bounce modifier, click the D key to enable the debug options, and let's start typing here the values. So let's start -20 on each field and 20 on the bottom row. So you will see that now we have bounce set up 20 centimeters away from the pivot point in both directions. For example, let's first fix the vertical alignment. So we don't need negative start in the vertical direction. So let's start from 0. And for the max value, let's put 100. So this is properly setting the bounce for our desk from the 0 to 100 centimeters point in the Z direction. Let's fix now the other directions. So let's put -50 here. It will need more, -200, for example, -250. Okay, and into the other directions, 50, 45, 40, let's say 45, or 40, it's closer to the edge. Okay, and now the last direction, -50, -150. Okay, now it's matching this side of our desk, and let's match the other one. So your bounce should look like this. Actually, one of them is still protruding. Let's put -260 here. It's closer now. So now that our desks are better matching the bounce that the boxes are descripting, let's disconnect our spawner here and let's connect it back into the bounce modifier. So let's disable the debug here. Let's go back to the sampler and put it 120 by 100. And here between the bounce modifier and the spawner, let's out click on the link to remove it. Let's drag out and put a self-pruning node. And with this node, you see that it will remove all the desks that overlap each other based on this bounce. So I have a lot of overlapping bounce here, but if I debug the self-pruning, it's removing all the nodes that are overlapping each other and just leaving the desks. So what can we do to randomize a little bit the placement of these desks? Let's move a little bit away from the wall here because some of our desks are getting into the wall. Okay. So now we can add some randomization before the spawning of the desks. So let's disconnect this here, and before the spawning, let's do a transform points. Let's connect it, and let's say we'll add random rotation from 0 to 180 degrees. This will randomize the placement of the desks, but it just looks chaotic. It doesn't look believable. at least to me, that anybody will place the desks inside a room that way. So I prefer not to do it that way. I prefer to split the desks into a couple of groups and rotate them by some fixed angle. And let's see how we can do that. Instead of transforming all the points by a random value, let's remove this node. And now let's create an attribute noise. And for the attribute noise, let's put into both of the fields the density. So we'll get the density and set it to a random value from 0 to 1. So let's preview this. Now before the attribute noise, all the boxes have their density set to 1, that's why they're showing white. And after the density noise, they have a random value from 0 to 1. You can see if I select the attribute noise and change the minimum to 1, it's exactly like before, everything is set to 1. If I change the minimum to 0, they randomly get a value from 0 to 1. And after I get some random values, let's do a point filter. And this filter will check if our density is bigger than 0.5, so the operator will be greater than. Then we'll choose the density value. We'll use a constant threshold, so mark this box here, and we'll put the value 0.5, and this will select values for inside the filter all the boxes that are white or close to white with a density value of greater than 0.5, and outside filter here we'll get all the boxes that are closer to black or a value from 0 to 0.5 in the density. So let's get, for example, the inside filter once, and let's do a transform points like we did before, but instead of randomizing the rotation from 0 to 180, let's put a set rotation into both fields to 90. That way all the desks that are with density over 0.5 will get exactly 90 degrees rotation. Now let's merge the desks that we are not rotating that are outside the filter and the ones that we are rotating inside the filter. Let's debug this point. So now you have some of the desks rotated. You can see the lighter values like these white boxes. They are rotated 90 degrees compared to the darker ones. So let's disable the debug, connect this to the spawner, and now half of our desks are rotated by 90 degrees from the other half. Let's spawn a chair for each of these desks as well. Here we are spawning the desk, and let's do another transform points, and then let's do another static mesh spawner, and into this spawner let's create a mesh entry, and let's choose into the descriptor static mesh. That is the chair. Now the chair is placed on the pivot point of the box that we are placing with the PCG. So let's use this transform point that we created to offset it. For example, let's offset it by -100 in this direction, and then random value between -100 and -200 in this direction. So each chair is randomly more close or more far away than the desk on the left. Let's put some randomization on the other directions as well. Into the vertical direction, which is the last field, we don't want any randomization because the chairs will pop in the sky. So let's leave that to 0. And let's have some random rotation into the z-axis. So we'll get them actually from 0 to 90 degrees random. So some of them will face towards this desk, the big part of the desk, and some of them will point to the small part of the desk. That way we are getting some kind of randomizations with the chairs. If we debug the transform points that we're placing the chairs, you see that the bounds are completely wrong because they're set for the desk. So let's disconnect and have our chairs have a new bounce modifier. Let's debug this, set it the value to set, and use again the same kind of strategy like before. Make a small cube and try to edit it to match better the shape of the chair. So 0 to 120, for example. No, it's too tall. 110 for the vertical direction, and for the other directions let's -20, -30 to 30, maybe -25 to 30, and then into the last direction -20, -25 to 30. This is better matching the chairs. Okay, let's remove this, debug visualization. So now that we are placing these desks and the chairs, the next part will be to start placing some random tables around the desk. We'll go back to the spline sampler and use these points. So we have this grid of placing objects everywhere. Now let's create a new bounce modifier for the tables that we will be placing. Let's create a difference node because we don't want to place tables on top of the desk that we already have. So into the difference, into the bottom input SWOT where it says differences, let's connect this value here, which are the parts where we have the desks. So let's now visualize this. So the difference, you see, if we debug it, it's excluding these parts where the values, where the desks are overlapping with the point grid that we are making here into the sampler. So let's change the options for the difference. Instead of these default ones, let's change this to binary. And that way it will just exclude the points, it will not give them another value. And this will be more easy for us in this particular case. We don't want to spawn any table over the desks. Let's again do the same as before. Let's use attribute noise to get a random value for each point. So disable the debug visualizations here and do it on the attribute noise. So now you see not all the cubes are white. Now we have a random value for each of them. And now we'll use this to filter them. So let's do a density filter. Let's visualize the filter. So now we are removing all the points that are with density outside of this range. Let's change the range, for example, to like this. So we'll only get the very low density values like this. Let's do a transform points to randomize them a little bit. For example, let's randomize the rotation from 50 to 100. You'll see these tables will get some random rotation because they are presumably moved and nobody is aligning them very specifically to the desk. These bigger desks are hard to move, so they're placed in this grid fashion, but these tables are movable, so we can have some random rotation for them. And after we randomize the rotation, let's randomize a little bit the placement as well, for example. And now let's do a static mesh spawner again, and we'll create the two mesh entries. The first one will be this kind of desk, and the second one will be the wood one. So we have some different type of desks here. Let's show this transform points. You see that we are not matching very well the shape with the size of the object that we are placing. So let's go back here to the beginning and let's change this bounce modifier. Let's set the bounce. Let's use the same way as before by getting a little cube and changing its size. These two type of tables are close to each other sizes, so we'll just use this one spawner and do it like this. Let's say we'll get 95 here, minus 30 to 30, minus 50 to 50. I think this is close. And here we have them overlapping a bit. So to solve this, we can do here a self-pruning instead of just spawning directly on each point. And now you'll not get any overlapping parts. Because we are randomizing the transform, you can get them to go inside the big desks. For example, if we randomize with bigger values, they're overlapping with the desks. So maybe you can do another difference here in the end. So let's copy the difference node. Let's do our final points after our transformations, and let's add into the difference the desks, the bigger desks. That way you see that no longer any table is inside of the big desk. Let's now choose the density filter and give it a little bit of higher value, because now we get a very little of these smaller tables. So let's increase the filter, and as we get more and more of these tables, neither is intersecting another small table or the big desks, because we are using the self-pruning and the difference with the bigger desks. So by the same logic, we place other objects into the scene. For example, the cables below the desks. So let's get this point sampler result here. Actually, we'll get the result here after we already determined where each of the big desks is. Let's do another transform points. And let's do a static mesh spawner. And this spawner will have a mesh entry with the cables. I can't really see into the preview which ones. Let me search here how is the name of the cables to use. This wire A1. So let's go back here. Let's select the wire A1. Now we are placing wires below each desk. Let's randomly rotate them between 0 and 180. Let's do a random offset minus 100, let's say minus 50 and 50, minus 150. So now below each desk we have some cables which are randomly placed and randomly rotated. We have a little bit more randomized look. We have a randomly placed and rotated chair. We have some random tables around the room, the smaller ones. Now let's start placing the objects over the desks. So we'll start with placing the monitor, the computer and the keyboard, and after that we'll place some random set of objects on top of the desks. Let's go into the tutorial PCG graph. Let's again select the point where we have the one point for each desk. Let me visualize this. We want a monitor for each of these big desks. So let's disable the debug. Let's do a transform points, and let's do a static mesh spawner. And in this spawner, let's create an entry. Select the monitor. To get a little bit more variation, let's create another entry and let's select the other monitor. So we'll randomly place one of two monitors. Currently, they're being placed on the ground. Let's use the transform points node that we created to move them. So we know the desk is 100 points tall, so we'll offset by 100 into the Z direction. We need to rotate the monitor 180 to face the part where the chair is. And now every monitor is placed exactly in the same spot on the desk. So let's randomize a bit the offset. Let's first explore what's the max value we can use. So let's put, for example, 50 into both values for y. It's too much, so we know that we can maximally offset by 20 the monitors. So let's randomize now between 0 and 20. So now each monitor is up to 20 centimeters away from the back side of the desk. Now let's do the same with the other X value. Let's say we move it 100, it's too much. 80, 70, 50. Okay, 50 is about the maximum amount we want to get in this direction. And for the other direction, 150 is too much. So 100 is probably the max that we want. Let's be on the safe side and put 80. Okay, this looks fine. So we will use a random value between -80 and 50. So now we get a little bit of randomization where the monitor is placed on the desk. Actually, -80 will be too much because we will need to place the computer besides it. So let's do -60 to 30, something like this. So we can have the option to place the computer or one of the sides of the monitor. So now we have a little bit of randomization of the placement. Let's do a random rotation. Let's not rotate all of them 180 degrees. Let's get a little random angle for the monitor. So 150 to 200, 160 to 200. That adds a little bit of randomization into the facing of the monitor. And we can do the same as we did for the desks. So we want some of the desks to have monitor like the one we have now, and some to have it on this bigger part. So instead of connecting directly to these transform points, let's disconnect by out-clicking the connection. Let's create first attribute noise. We'll set the density from 0 to 1. Then we'll filter the points. We'll get the ones that are over a constant, which will be, for example, 0.25. And then we'll do another point filter. Because we are getting the desks between 0.5 and 1 and we are rotating them. Now we'll get the points between 0.25 and 0.75. So this will be below. This will be a fixed threshold and 0.75. That way we'll get half of the desk turned the one way and half of the desk turned the other way. And we'll use this filtering to transform the points for the monitors. Let's copy this spawner, the static mesh spawner, and let's transform now this monitor to be on the other part of the desk. So let's rotate it -90 degrees. Let's move it and now let's randomize the placement on the side of the desk. So between -80 and -150. Let's see how it's -200. Okay, we can minus 180 for example and minus 50. We'll get random placement for half of the monitors that will be on this big side of the desk. We'll place them randomly along this part of the desk. So let's get the outside filters here from this one and this one, and let's merge them. And then let's place the monitors that we had before on the other parts. So now we have half the monitors placed on the big side of the desk and half the monitors on the small side of the desk. These spawners are the same, so actually let's delete them and let's merge the results of this and use a static mesh spawner here. And let's choose again the two monitors. Now I have the two monitors placed here, and I have here the points for the monitors. They have a huge bounding box, so let's fix that before applying the attribute noise, or after applying the attribute noise. Let's disconnect here. Let's do a bounce modifier, and let's do the bounce like this. I think this fits both monitors pretty well. So I have now here the points for all the monitors, and we will be placing the PC and the keyboard using the same points. So drag out of these points, do a transform points. Let's do same here, and let's static mesh spawner. Let's copy it 2 times. So the first static mesh spawner, it will spawn computer tower. Let's use this one, and we have another computer tower, so to have it better randomizing, let's choose the other tower. So we have two computer towers here, and here we'll have the keyboard. We have two keyboards as well, so let's create another entry here and choose a keyboard. Okay, so we are placing a computer and keyboard for each monitor. So let's adjust the transform points for each. Let's start with the keyboard. So based on the monitor position, let's offset the keyboard in Y by 50. It's too much. Let's say 40. Okay, 40 is the max. Let's say 30 to 40 centimeters. So it can be closer or further away from the monitor. Let's rotate it minus 20 to 20 or minus 15 to 15. Let's randomize the position along the x-axis, minus 20 to 20. So let's look another one. Here you can see we have the other keyboard. It's rotated some other degree and it's placed a little bit sideways from the monitor. So now let's fix the PC cases. Let's offset them by by 50 into the x-axis, and let's randomize this. Let's say 40 to 60. So now some of the monitors are closer and some of the monitors are further away from the PC. Let's move them a little bit closer. Let's test actually. 30 is too close, so 35 to 60. So now we have some of the PCs being close and some being far away from the monitor. Let's randomize a little bit the rotation, minus 10 to 10. We have some big monitors, some small monitors, and big box, big PC and small PC, as well as two different keyboards. So we have a lot of variations. We can again filter the PC placement like we did before. So let's make an attribute noise. Let's make a point filter. Let's do density over fixed amount, say 0.5 or 0.4, to get some of the desks that are rotated one way. So inside the filter we'll do another transform points and we'll move them. For example, let's disconnect and connect here. We'll move them minus 50 in this direction. So it's too little, minus 100. Okay, so now some of the PCs are on the side of the monitor. They're actually too far away back. Let's check a little bit to the front. So now we have the PCs better standing on the desks. Now we can start to place little objects on top of the desks and the tables, so the environment can look a lot more detailed and natural. So let's open the PCG graph, and we need to find the nodes that are spawning the desks and the tables. So just use the D key on the spawn mesh nodes. So these are the ones for the desks, and I believe these ones are for the tables. Yeah. Sorry, I was testing here. So now let's merge the desks and the tables points. So drag out and choose the merge node. And now if we debug this node by hitting the D key, you can see we have the desks and the tables objects together. Now we'll do a bounce modifier together for them, and because we cannot set a single size for all of them, we'll actually use the scale mode here, unlike before when we used the set node. So for the scale, we'll scale them a bit down in both horizontal directions to not place objects on top of the edges. And then for the vertical direction, we'll scale it a bit up. So now if we show the bounce here, they're covering the desk and the tables. They're a little bit over them, in terms of vertical alignment and not covering the edges completely. So let's turn off the debug mode. Now right click here and use the world rate hit query. This will create rays from our bounding box in the given directions. The default directions here is -z, so it's pointing down. So drag out of this world ray hit query and do a surface sampler. And for the bounding shape, we'll use this bound modifier. Now, if we show this surface sampler, let's edit the options here. Let's make smaller objects, let's say 10 centimeters by 10 centimeters, and let's place, for example, 5 per square meter. Currently, the objects are placed on the ground. This is because our world ray hit query is set to collide with world static objects, and in our static mesh spawners, for each mesh we are spawning it with this collision preset of block all dynamics, which is a world dynamic object. So let's change here the world rate hit query to world dynamic, and the points disappeared altogether. We need to uncheck this ignore self hits in order to have the PCG graph hitting objects spawned inside this PCG graph. So now when we are debugging this surface sampler, we are getting hits over our desks and tables. I get some on the ground here, and if you don't want this, let's overwrite the default parameters for the world rays that we are casting to search for objects in the scene. So overwrite the parameters. Let's say we'll start with origin of 7 meters. The direction will be downwards, and the ray length will be 200. So if we are making the rays shorter, they are not reaching the ground, and we are not placing objects on the ground. If I make it even shorter, it will not even reach the desks. So 200 here from my tests is a good value. But now, unfortunately, you can see we are placing objects on top of the chairs, on top of the monitor, and we are placing objects intersecting with the computer and the keyboard. We don't want this. So we need to do an exclusion like before. So copy the difference nodes from before. We'll get this as a source, and we'll combine the computer, the keyboard, the monitor, and the chair. So drag out from the chair, do a merge. Now here is the computer, the keyboard, and the monitor. So now if I disable the debug on the surface sampler and enable only the debug here on this merge node, we are merging the computer, keyboard, monitor, and the chair. So we will be excluding this into the difference. And now remove this and show only these points. If I show the points before the exclusion, the difference node, you can see it's placing objects on top of the chairs and it's intersecting our other objects on top of the desk. But if we debug after, it is only placing objects outside of the computer monitor and keyboard and not placing anything on the chairs. So with these points, let's turn off the debug. Let's do transform points like before to get some random placement. And let's do a static mesh spawner. Here into this static mesh spawner, I'll have a lot of entries to place some random objects. I'll just copy it from my other example. Here I have 8 objects to be placed. I have chosen some big objects because I will be spawning on top of them another set of objects. You can pick better the objects for these steps. For example, don't pick this object because you cannot place anything on top of it. Or this one maybe. You can just choose what kind of objects you would like to have. And because they are currently overlapping each other, like we did before, let's disconnect by out-clicking here and do a self-pruning node. Now we are no longer overlapping the points. Actually, we are overlapping here, so let's show our points with the D key, the debug. The reason this self-pruning is not working properly is because our bounding box is too small. Let's do a bounce modifier. Let's connect it here and let's debug this bounce modifier instead of the previous node, and let's use the set. Let's set the bounce it's still a little bit too big. Okay, so closer to the shapes that we are placing. Then if we stop the debugging, the self-pruning is working a little bit better now. We are not getting overlapping parts. Here into the transform points, let's add some random rotation in order to have it a bit more randomized. So now what we can do is use these objects that we already have in the scene as well as the desks themselves. So here I have my desks and tables. So let's merge them with our result of the placement of the big objects here. And let's use this point as a bounding box for another world ray hit query. Let's copy these two nodes, the surface sampler and the hit query. Let's connect this as a bounding shape. And now if we debug this surface sampler, you can see it's placing the objects on top of the desks and on top of the objects themselves. Let's do again the same difference. So connect the same object as before into the difference, and now our new output as the source. Now we get objects on the desks as well as on the boxes that we placed on the desks. Now let's do another transform points. And let's do another spawner. I'll copy it because it has a lot of objects as well. I have 16 different type of objects set up here. For each of them, go into the descriptor and choose some static mesh objects from the pack with the items. So I have it here set up already. Let's connect it. And now we are placing objects all over our desks and the big boxes that we placed on top of the desks. So you can add some random rotation. You can have some more objects by doing this more points per square meter. Let's say we'll have 10. Maybe reduce the size here. And this way you can easily populate your scene with objects that are randomly placed but still are following some logic, like the orientation of the desk, the placement and orientation of the monitors, and then just filling in with objects on top of everything to get the detail look. You can add more spawners as well, doing the same logic. You can add filters to divide the objects in different types and then do a different placement logics for each of them, like we did for the desks or for the monitors, in order to have them on the left, on the small part or on the long part of the desk. So I hope that this really shows you how you can combine different spawners and different type of logic into the same graph to achieve this more natural, realistic kind of placement in your scene. And you can easily populate your levels. You can go and add this blueprint a couple of times in your scene to easily populate your scenes. Let's add another one here. It's so easy to get another room decorated with this. Just adjust the shape of the placement curve and you're ready to go. If you have any questions or if you want to ask for a tutorial for something specific, please write in the comments. It will help a lot if you subscribe and like this video. So see you in the next tutorial, guys. Bye.